Permutation is when ordered matters and combination is when ordered does not matter. And essentially we have to make sure we don't count things twice, and you should only count things once. And there, if we do everything is a permutation, you always overcount. So you gotta have two. So here's the first one. In a group of 10 people, a $20 bill, $10 bill, and $5 bill price will be given. How many ways can the prices distributed? This is a permutation because order matters, and it matters who gets the 20, it matters who gets 10, and it matters who gets 5. So guys, this is our last example to this lesson. So here's the example. A local school board with 8 people needs to form a committee with 3 people, and how many ways can this committee be formed? So guys, in this case, it is a combination, and because the order doesn't matter, and they are committed, and they have all equal jobs to do. So the formula, guys, is A 3 and is equal to 8 factorial over 5 factorial and 3 factorial. So the answer is 56. So 8 factorial over 5 factorial divided by 3 factorial is equal to 56. Again, you can also use calculator to solve this. So that's it, guys. Thank you for watching. We'll move on to the next lesson, the Z table. So in this video, we're gonna go over to the lesson standard normal distribution, as well as some equations that you will need to be familiar. And after that, we're gonna work on some problems so that you could use and see on how to put these formulas to good use. So the normal distribution has the shape of bell curve. It looks something like that. So now the notation for it, perhaps you have seen this in your book. So in normal distribution, you have 2 important parameters that you need to know. That is the mean and the standard deviation, represented by that symbol. This symbol called sigma, that kind of look like Fiat Emma. Okay, so now the mean is right in the middle here. It's in the middle of the bell curve. This. And here would be a standard deviation, and And here, standard deviation away from the mean. -1, +1. That. The z-score that corresponds to 1 standard deviation is simply 1. So z is equal to 1 when the z-score is less than the mean. The z-scores are negative, so -1 there. So we put on some numbers here, 2, 3, -2, -3. So z 2, z -2, z -3, c +3, right there. Now the formula you need to calculate the z-score is the formula is this: c to calculate the z-scores is equal to x minus the mean divided by standard deviation, like that. That's the formula in this lesson. But sometimes you may need to calculate x. Sometimes we need to calculate for the x. So the x is equal to mean plus c times standard deviation, like that. So these are the formulas that you want to make sure you write down for the problems that we will solve. So guys, this is our first problem. Number 1, first problem. Normally distributed IQ scores have mean of 100 and standard deviation of 15. Syempre we should use z-table to answer this following questions. What is the probability of randomly selecting someone with an IQ score that is A, less than 80, B, greater than 136, C, between 95 and 110, D, what IQ score corresponds to the 90th percentile, and E, the middle of 30% of IQ falls between what two values? Yeah. So first, let's solve 80. Okay. So the mean is 100 and the standard deviation is 15. So now let's draw a picture. Guys, sorry for my drawing not good at this. Dugyot ako, dugyot. And the mean is 100, and we will find a probability of selecting someone with a score less than 80. So you share 80, less than, so negative, right there, 80. So what we need is the area to the left of 80. I'm gonna shade it like that. So the first thing we're gonna do is to calculate the z-score, and then we could use the z-table to get the area under the curve. We're going to use z-table. So we know that formula z is equal to x minus m over standard deviation. That's what we're going to use, guys. Yeah. So the x is 80. X is 80. The mean is 100. And the standard deviation is 15. And we're gonna find the probability that x is less than 80. So we're gonna say x is 80, the mean. Yeah. So guys, we're going to use a calculator. So first, let's solve 80. Okay. So the mean is 100 and the standard deviation is 15. So now let's draw a picture. Guys, sorry for my drawing not good at this. Dugyot ako, dugyot. And what the mean is 100 and we will find a probability of selecting someone with a score less than 80. So you share 80, less than, so negative right there, 80. So what we need is the area to the left of 80. I'm gonna shade it like that. So the first thing we're gonna do is to calculate the z-score, and then we could use the z-table to get the area under the curve. We're going to use z-table. So we know that formula z is equal to x minus m over standard deviation. That's what we're going to use, guys. Yeah. So the x is 80. X is 80. The mean is 100. And the standard deviation is 15. And we're gonna find the probability that x is less than 80. So we're gonna say x is 80, the mean. Yeah. So guys, we're going to use a calculator. So guys, let's first solve the IQ score that is less than 80. Okay, so we all know the mean is 100. Standard deviation is 15. So this the mean in the center, less than 80, so negative. Shade the left side of that because it's negative. When it's greater, so here, wait. Okay, so it's negative. Now the formula. So z is equal to the 80. The x is here minus the mean is 100 divided by standard deviation of 15. So we're going to find the probability of x is less than 80. Okay. So we're going to use a calculator. Here. So 80 minus 100 is equal to negative 20 divided by 15. So yeah, 1.33. So we're going to this 1.33. As you can see, it's repeating, but we're gonna stop at 2 decimals, so 1.33. So what to do to this point is, at this point is use the negative z table. Get that? And find the area, the value in C table, 1.33. That. So find the area that corresponds to the C value, like that. So using the table, so the value on that Z table is equal to 0.09176. If we're going to multiply that on 100, it will be equal to 9.9. If you're going to multiply on 100, it will be 9.176%. So that is the percent of selecting someone with an IQ score less than 80. So this is the answer. So now let's move on to the part B, greater than 136. I will use another paper because I think it seems enough space. So guys, we're going to use again this problem. Now we're going to letter B because we are done in letter A. Letter A is less than 50. We get the score. We get the percentage here. So letter B, what is the probability of randomly selecting someone with an IQ score that is greater than 136? So again, mean. This is our mean. Okay. This is another paper for that because we have enough space. So mean 100 and standard deviation is 15. So again, the mean is in the center. 136 is because greater than, so positive. Now we're going to use this area and the probability of greater than 136. So again, x to 36, this formula we're going to use. So z is equal to 136 minus 100 over 15. So again, 136 minus 100 is 36. We're going to divide it to 15. That will become 2.4. Okay, so let's type 2.4. The z value is equal to 2.4. So we're going to convert the value of 2.4 to the area value. So if you will find it on the z table, it will become, if you're going to find that on z table, guys, it will be, okay, value is equal to 0.9918. But that's not our answer yet. So we're going to find this area highlighted in 136. So it's going to be P where X greater than 136 0 to 1 minus B X to 136. So the answer we have here, that corresponds to the probability that, so this probability corresponds to that either X is less than 136 or greater than or equal to 136, because it's going to be the same. So while here equal here is we're going to do 1 minus 0.9918 right there. So the answer to that will be, let's see a calculator. So that 0.008 right there. So there's a possibility that 0.82 2% chance that a person selected at random will have an IQ score of 82%. This is our answer to part B, 0.82%. So guys, now we are done to part B. We get the answer here. Now we're going to letter C. What is the probability of randomly selecting someone with an IQ score that is less than is between 95 and 110? Okay, so let's answer this. We're going to use this paper because we have enough space here. Okay, so let's use this. Again, mean 100, standard deviation is 15. If we have 2x, so here less than 95, between 95 and 110, going to this 95, and we will shade it right there, like that. So we need to calculate this area, the region we shade. We're going to calculate this area between 95 and 110. In order to do that, to calculate the probability that X is between 95 X 110, this we need to know the difference of the probability that the 110 so 110 and minus 95, like this, right? $110 right there, minus 95 oh wait this is wrong, sorry like that. We're going to calculate for 110, so equal to z equal to the mean, the formula is we're going to use this x and standard deviation formula. So 110 minus 100 over 15. It's going to be like, it's 10 minus here. We all know that 110 minus 100 is 10. So we're going to use calculator for 10 divided by 15. So 10 divided by 15 is equal to, it could be continuous 2.6. So we're going to use the two decimal numbers. So it will be round off. So we're going to be 0.67. Okay. That will be 0.67. So that's it. Later we'll determine the value of that to z table. First, I want to solve first the z score. So 95 minus 100 to 15, so equal to 95 minus 100 is equal to negative 5. Negative 5 divided by 15. Again, we're going to use a calculator. Negative 5 divided by 15 is equal to 0.3. So we're not going to round that off because the number on two decimal is 3 and the right side number is also 3. We're not going to round off that. So this 0.33, that's our 2 score. This is score 110, 0.67, 95 is 0.3. Box. Okay. So guys, if we found it on Z table, these two area available on that is 0.74857 and 0.37070. There. We're going to find it on C table. These two. So this probability corresponds to that. Probability is less than to 110, and this corresponds to the probability less than 95. So let's go ahead and subtract these two values. 0.4857 minus 0.37070. Again, we're going to use calculator for that. So right here, 0.74857 minus 0.37070. 370 is equal to right there. So this is the answer, 0.37787. Now this is the area under the curve between the x values 95 and 110. Okay, let's type here. Sorry for the spacing again. It's equal to 0.37787 right there. Oh, so we could say that there's a 37.787% that probability of randomly selecting between 95 and 110. So this is our answer in part C. The percentage of 95 between 95 and 110. Okay. This is final answer. Sorry for the spacing again. Oh, I will use arrow. I will use arrow in this right there. Yeah. Peace.